So in this video, we'll be covering a Figural series completion guide, which will encompass everything you need to know to complete these Figural series questions. So let's start with what you'll see so you know what to expect. So each question will show a sequence of between 4 to 5 frames, where these frames are otherwise known as figures, that show a pattern that evolves from left to right. However, one of these frames is missing, and your job is to identify the rule or rules behind the changes and then select the option that completes the sequence. Now, I said rule or rules because many series will simply use one repeating rule. However, some will use 2 rules that alternate. For example, odd versus even frames, and we'll see some examples later on. Now let's talk about the main solving method. So by main solving method, we mean that this is the default method to answer most questions. So starting with number 1, compare consecutive frames. Now remember, the pattern is evolving from left to right. So you want to start with frames 1 and 2, starting first at 1 and then looking the change to 2. And then you can look at 2 and how 2 changes to 3, and so on, all the way to the end of the sequence. So again, once more, the pattern evolves from left to right, and you have to compare consecutive frames starting from the left and then moving right. Then we have 2, describe the change in one sentence. So for example, we could say the dot moves 1 corner clockwise. Of course, the description will depend on the specific sequence, but this would be an example of how you can concisely describe the change. Then we have 3, test the same sentence on the next step. So in our example, the dot moves 1 corner clockwise. Let's say we identified that as something that applies from 1 to 2. Now we want to take that same sentence and apply it from 2 to 3. Now if it holds, it's very likely that you found a real rule. But if it breaks, then you should refine the sentence or consider that there may be a second rule. So you'd return back to step number 2 and continue again from there. Then we have step 4, confirm across all given frames. Now, when you look from 1 to 2, you identify the change, you describe it, and then you test it on the next frame. So from 2 to 3, you'll want to actually confirm that this applies all the way. So you can't assume that just because from frame 1 to 2 and 2 to 3 that it works. You should confirm across all given frames. Then we have step 5, predict the missing frame before looking at the answers. So this goes essentially hand in hand with number 4. So you should do your best to, after checking the change from 1 to 2 and 2 to 3, for example, before looking at the result from 3 to 4, you can go ahead and predict the missing frame and then go ahead and confirm it by looking. And then last, we have 6, match the best answer choice possible. So if more than one answer option fits, then your rule is incomplete, and you should add one more feature and repeat the process. And together, again, this makes the main solving method. If you master these steps and learn how to apply them diligently, you should be able to answer the majority of these Figural series questions. Now let's go through a worked example. And here we'll use the main solving method that we just discussed. We'll start by stating a rule, test it across the given frames, predict the missing frame, and then eliminate choices. And in this example, you'll see why your first rule is often correct, but not necessarily specific enough. So first of all, let's take a look at our series. We have 5 frames in total. The 5th frame is the missing frame. And now let's look at the pattern we see unfolding. So remember, the pattern evolves from left to right. So we're always going to start on the far left with frame 1. So in frame 1, we have a box with 1 stripe. In frame 2, we have 2 stripes. So 1 more stripe was added. In frame 3, so now comparing frame 2 and frame 3, we can see that yet again 1 more stripe was added. We have 1, 2, 3. And then finally in frame 4, we have 1, 2, 3, 4. 4 stripes. So the change from frame to frame appears to be the addition of 1 stripe. And therefore, for theory 1, we can write the rule, each frame adds 1 more stripe. Now, we can test this, and that's exactly what we just did, and we know it to be true. So that was the basis for writing the rule. we conducted the test, and therefore our prediction would be that this missing frame 5 should have 5 stripes. So with that, we can take a look at our answer options and see which ones have 5 stripes and which ones have more or less. And we see that answer options C and E, both of them have 4 stripes. So we can eliminate these as answer options, but we find that we still have 3 potential answer options. We don't have only one possibility. So therefore, we know we need to refine the rule, and we can start by defining a new rule for theory 2. So for theory 2, we can write the rule: the number of stripes grows and stripe thickness alternates. Thin, thick, thin, thick. So we didn't identify this when we initially looked at the series, but if we look more closely, we see it's not just one stripe that's being added. Not every stripe is the same. We see we start with one thin stripe in frame 1, and then in frame 2, we have a thin stripe and a thicker stripe. Then in frame 3, we have thin, thick, thin, and frame 4, thin, thick, thin, thick. So this rule is sensible. It is alternating between thin and thick, and as we've just seen in our test, the pattern is consistent across all the frames. And therefore, we could predict that the missing frame not only adds 1 stripe each time, but that the stripe will alternate between a thin and a thick stripe. So if we return to our answer options, we can therefore eliminate answer option A, because answer option A only has thin stripes. But again, we still have 2 possible answer options. We have B and D. Now, before we redefine the rule for a theory 3, what's the difference here? Well, we see in frame 1 up top that we have this thin stripe to start. And in B and D, in B's case, we start with a thick stripe, and in D's case, we start with a thin stripe. So therefore, we can write the rule: stripes increase by 1 each frame, thickness alternates, and the top stripe is always thin. And again, this is what we've worked through. We know it starts with this thin stripe. We know there are 5 stripes in frame 5, and we know that there's alternating thin and thick stripes. So therefore, we can eliminate answer option B, which starts with that thick stripe, and we now know that answer option D is our correct answer. So in the previous worked example, we essentially had one key feature, which was stripes. That is what defined the sequence or the series. But for these figural series questions, there will be a wide variety of potential key features. So let's remind ourselves of them. And for more information, you can go to the description of this video to find a link that will take you to a different one of our videos that discusses the changes that you can expect in figural reasoning. And as a note, when you look at figural series questions, you don't need to go through each of these very thoroughly and systematically, at least not necessarily. You should scan for these features consistently and quickly, but again, you don't need to analyze all 8 in a deep manner. Just do a quick scan and then follow the strongest signal. Now, with that said, let's go over some of these key features. The first one is the count. So we're talking about the number of something. So that can be dots, shapes, segments, lines, or more similar to the previous example, stripes. So you should count the different elements and see if that plays a role in the pattern. Then we have position. So there's several different positions you should keep your eye on. Corners, edges, and the center of a specific frame all should get due attention. Then we can also have quadrants or inside-outside features. So position is also key. Then third, we have rotation and direction. So perhaps frame to frame, things are rotating by 90 or 180 degrees. If there are arrows, maybe at first it's pointing to the left and then it starts pointing to the right, change of direction of the arrow. And likewise flips or reflections. So pay attention to the orientation, how that's changing from frame to frame. Then we have 4, size. So of course, growing and shrinking are things, whether it be everything in a frame or just parts of a frame, are they getting larger or smaller, or as we saw before, thicker or thinner. Then number 5, we have fill, color, and shading. So some frames may be solid, others empty, or again, striped. Then for 6, we have the shape identity, so the type of shape. So perhaps you have a frame that goes from a triangle to a square, for example. And then again, in the examples where we have an inverting or an exchanging of positions between inner and outer shapes, the the shapes can be swapped. So what was an inner shape can become an outer shape and vice versa. Then we have order or movement. So this can be clockwise or counterclockwise cycles most commonly, and there's a bit of overlap here with the position and the rotation. These are somewhat interconnected. And then we have, last but not least, symmetry or mirror. So left, right, or top, bottom reflections. Again, we talked about this briefly up here in number 3 for rotation and direction, but you should always be looking for patterns in terms of their orientation and position, and these are just more specific ways of conceptualizing the types of changes that you might see. So keep this list in mind. Again, no need to go through it comprehensively each time, but here you have a convenient reference to have all of the key considerations at your fingertips. So now let's talk about some of the more common types of figural series questions. And we'll start with arguably the simplest and the most common, which is single process. And a single process type problem is where all differences between the elements can be reduced to one repeating rule. So this is about as straightforward as these figural series questions can get. So we'll go ahead and take a look at an example. Here we have 3 different frames. We have frame 1, frame 2, and frame 3. Now, in this series, the shapes follow a cyclic change of size. So this is specifically called a cyclic permutation. And what this means is that the position of each shape is cycling. So for example, let's look at frame 1. We see we have an outer triangle, we have a middle square, and we have an inner circle. Then here in frame 2, let's look where each of these shapes goes. So again, we have an outer triangle, and in frame 2, the triangle is in the middle. So it goes from outer to middle. Then in frame 1, we have a middle square, and in frame 2, the square is inner. So it goes from the middle layer to the inner layer. And then lastly, looking again at frame 1, we have this inner circle, and this circle becomes the outer shape. And if we were to compare 2 and 3, we'd see the same thing. In 3, we see a change from 2 such that every position is shifted in the exact same manner. The outer circle becomes the middle circle here in 3. In 2, we have a middle triangle, which becomes an inner triangle in 3. And then the inner square goes to the outer position. So the rule more definitively or more concretely is that the outer shape becomes the middle shape becomes the inner shape, and the inner shape becomes the outer shape. But let's bring us back to the key idea here, what you really should focus on taking away, which is that if one rule explains every step, as it does in this case, then you can predict the next frame simply by applying that very same rule again. So let's go ahead and do that. So if we were going to go from 3 and predict 4, let's use our rule. The outer becomes the middle. So in 3, the outer is a square. So let's go ahead and draw a square here, considering that it will be in the middle. Then the middle becomes the outer. So we have this circle as the middle shape in frame 3. And therefore, the inner will be a circle in frame 4. And then lastly, the inner becomes the outer. So the inner in 3 is a triangle, and therefore the outer in 4 will be a triangle. And this is indeed the correct depiction of frame 4. But what do you notice? Actually, these two are the same. So it completes a full cycle every 4th permutation, and it will do so again and again so long as the series persists. So another common type of figural series is the multi-process type of problem. And here, the differences between the elements can only be described as a combination of 2 or more processes that happen at the exact same time. So of course, here we have an example which we will work through. But what you need to know is that in this series, the arrow will undergo 2 changes simultaneously. Again, this is no longer a single process. This is a multi-process problem. So let's take a look at the example and see if we can identify what these 2 processes are. So we see here in frame 1, and we can go ahead and label all of our frames. But in frame 1, we have a box or a square where in the bottom right-hand corner, we have an arrow, and the arrow is pointing to the left. Then, if we look at frame 2, we again just have a box with an arrow, except now the arrow has changed position and orientation. So instead of being in the bottom right corner, it's now in the bottom left corner. And instead of pointing to the left, it's pointing down. So in terms of movement, it moves one corner clockwise in each step. So clockwise, if we want to superimpose this on frame 1, would be in this manner. So therefore, our next position in frame 2 is here, one corner clockwise in each step. But at the same time, the arrow is also rotating and in the opposite direction. So for frame 1 to go to frame 2's position, in terms of the arrow, it's going to have to rotate 90 degrees counterclockwise. And that is what we see. Those are the two changes. It's a movement, moving one corner clockwise each step, and a rotation, rotating 90 degrees counterclockwise in each step. So the key idea here is, unlike the single process type of problem, where you simply must apply that single rule to predict the next frame, in this case you have to apply both processes to predict the next frame. So let's do that. We can go ahead and first confirm that this is consistent across all of the given frames. So if we look at 2 and we compare that to 3, we have a movement clockwise to the next corner, and that's what we see here with the arrow in this position in frame 3. And then in terms of rotation, it is a counterclockwise rotation of 90 degrees. So that would see the arrow move like this and be pointing to the right, and that's what we see in 3. So for all of the revealed frames, we know that this rule holds, and therefore we can use both processes to predict 4. So let's do that. We will redraw our square for frame 4. I'll label it again here. And we know first that the arrow is going to move clockwise one corner, and therefore it will be in the top right. But before I draw it, let's also address the rotation. So rotating counterclockwise 90 degrees means that it will rotate in this direction and it will be pointing up. So therefore, we draw the arrow in the top right corner and we draw it pointing up. And this is our frame 4. This is the correct answer. So again, you need to apply both processes simultaneously to successfully predict the missing frame correctly. So we've already talked about single process and multi-process figural series, but now let's talk about a third, slightly more different type, which is called alternating logic. And in alternating logic figural series, odd and even elements demonstrate different types of processes. So while this type of series is less common, it is still possible you will encounter them. So let's start as we did before and look at our example, and then we can work through this example to understand how this type works in practice. So first of all, let's label our revealed frames. We have 1, 2, 3, 4 revealed frames, and then we have a 5th unrevealed frame that we will predict using the rule derived from the revealed frames. So let's start with frame 1. Remember, the pattern always evolves from left to right, so we're always going to want to look at frame 1 and first see how it changes going from frame 1 to frame 2. So first of all, let's identify the basic structure of the frames. We have a circle, and that circle is broken down into quadrants, so 4 equal sized parts. Then we have 2 other elements. We have a white circle, which in frame 1 is sitting on the far left of the circle, the outer circle, and then we have 1 square, which is sitting in the top right quadrant. So how does the frame change from 1 to 2? Well, we have the same basic structure. We have the same outer circle, which is broken down into quadrants. We have this white circle, which is in the same position with the same orientation. We have the same square, white square, occupying the top right quadrant, but then we have 1 more square, now in the bottom right quadrant. So 1 square was added, and it was added to the next available quadrant, clockwise. So let's see if that's the rule. Does that hold? Can we apply the same thinking, the same pattern, going from 2 to 3? Well, if we could, we would expect frame 3 to have 3 squares. But we see that it still has the same 2 squares we see in frame 2. So what's going on here? What did change going from 2 to 3? Well, this time, the position of the circle changed. In frame 2, it's sitting in the same position as frame 1 on the far left of the outer circle. But then in frame 3, it's sitting at the top of the circle. It's moved by essentially 90 degrees clockwise to sit at a position at the top of the outer circle. So that's very strange. Going from frame 1 to 2, we added a square, but going from frame 2 to 3, we changed the position of the white circle. So let's think about this. What could explain this? Well, remember, this is an alternating logic type problem. So going from one type of frame to another might be one process, and going from a different type of frame to another might be a different process. So for example, we added a square on an even frame, but the position of the white circle changed on an odd frame. So let's see if that works. If we add a square to the next available quadrant clockwise in even frames, and then change the position of the circle, the outer white circle, by moving it 90 degrees clockwise, can we predict number 4, and then eventually number 5? So let's see. 4 is an even frame, so we would expect the position of the circle to be the same between 3 and 4, and it is. But we would expect an additional square, and in the next available quadrant, clockwise. And that's exactly what we see. We see one more square, and it's in the bottom left quadrant, so it's moved clockwise one quadrant. So therefore, this rule holds across all of the given frames, all of the revealed frames. So let's apply this to predict the 5th frame. Well, we can start with what we see in frame 4. We have this outer circle. We know it's broken down into quadrants. And then we have 3 squares already here. We have a square in the top right quadrant, a square in the bottom right quadrant, and a square in the bottom left quadrant. And then we have that white circle here at the top. So frame 5, that's an odd frame. So we don't expect to add an additional square. We expect to change the position of the white circle. So we would expect that this is rotated 90 degrees clockwise, and therefore, the circle will now be here on the right. And that is indeed the correct answer. This is frame 5. So the key idea for these alternating logic figural series is if step-by-step or step-to-step changes feel inconvenient, then you should check the rule and see whether it alternates between steps. So now let's talk about 2 supplementary methods to solve these types of problems. So different ways to solve figural series without that default method we've been focusing on so far. So this first supplementary method you can consider the eliminate fast method, and it's based on focusing on a single feature. And you should pick the feature that you can explain most intuitively and with the most confidence. So let's talk about this generally, and then we'll turn our attention to our worked example here. So in general, when a frame contains multiple moving parts, as we will see in this worked example, you shouldn't try to solve everything at once. Instead, you should first choose one feature, then predict that feature, followed by eliminating answer choices, and then, if more than one option remains, then repeat it with a different feature. And through this method, you can quickly eliminate wrong answer options and identify the correct option. So now, with that, let's turn our attention towards this specific example. So immediately you'll see there's a lot going on here. Each element includes 4 arrows moving inside a frame. So here we have this square frame, and then within it we have these 4 different arrows. We have a horizontal bidirectional arrow, we have a diagonal bidirectional arrow, we have an arrow pointing in one direction, down to the left, at least in frame 1, and then we have this curved arrow swinging up to the right. So again, there's a lot going on here. So instead of trying to solve the entire frame at once, you can track one arrow at a time and then eliminate answer choices. So for example, let's arbitrarily choose this horizontal bidirectional arrow. Let's see how just this is changing from frame to frame. So in frame 1, we see it sits here in the middle of the square to the right. Then in frame 2, we see it's still in the middle of the square, but on the left-hand side. Then in frame 3, we see it returns to the original position where we found it in frame 1. So this suggests that in frame 4, we should expect it back on that left middle position. It's what we see in frame 2. So then we can divert our attention to the answer options and eliminate where that would not be true. So D, for example, has this horizontal bidirectional arrow in the true middle, in both the X and the Y. So that's not correct. Then we see in A, we have the horizontal bidirectional arrow here on the right side, where it was in 3. So it's alternating. It's not going to be in that same position. So we can eliminate A. Now, both B and C have this horizontal bidirectional arrow in the right position, and therefore we need to focus on another element now to eliminate further. So now let's turn our attention back in the revealed frames to the diagonal bidirectional arrow. At first, it's in the top left, and then in frame 2, it's in the bottom right. Then in frame 3, it's back in the top left. So it's very similar with the horizontal bidirectional arrow, except instead of going from right to left, it's going from the top left to the bottom right and to the top left again, and so on. So with that, in frame 3, we see the diagonal bidirectional arrow is in the top left, which means in frame 4, we would expect to find it at the bottom right. In B, we still see it in the top left, so we can eliminate B. And this leaves us with only one answer option remaining. And indeed, we find this diagonal multi-directional arrow in the bottom right. So C is our correct answer. It's the only one that remains, and then you can still confirm the rule. But if you really want to be sure, you can repeat this process with different features. So for example, the curved arrow and one of the unidirectional arrows, and you'll still get the same result. But instead of starting over and choosing 2 new elements to compare, let's just roll the clock back a bit. So by comparing the frame-by-frame movement of this horizontal bidirectional arrow, we eliminated A and D. And then, to get to our final correct answer of C, we compared the movement frame to frame of this diagonal bidirectional arrow. But instead, let's start from the same point, but choose this curved arrow. So here we have this curved arrow in the bottom right of the frame, and it's pointing up. This is frame 1. Then looking from frame 1 to frame 2, we see that curved arrow has now translated to the next corner in the counterclockwise direction. So it's rotated within the frame by 90 degrees counterclockwise, and the actual arrow itself has rotated 90 degrees counterclockwise. So instead of pointing up, we see it pointing to the left. Now let's confirm this is what's happening again from frame 2 to frame 3. So again in frame 2, it's pointing to the left. It's in the top right of the frame. And then in frame 3, we see it exactly as already anticipated. It's translated 90 degrees counterclockwise, and it's rotated 90 degrees counterclockwise. So therefore, for this frame 4, if we look at our answer options, we would expect the curved arrow to be in the bottom left. So in answer option C, that's what we see, and we see it's also rotated 90 degrees counterclockwise as well. Then in B, we don't see that in that position. We see a unidirectional arrow, and that curved arrow is sitting in the exact same position as frame 3. So had we initially chosen this curved arrow instead of this diagonal bidirectional arrow, we would have still gotten to the same correct answer, which is C. So now let's talk about the second supplementary method, which is about using the answer choices to decipher the logic. And this is very valuable when the series doesn't click right away, when it's not obvious how to solve the problem or how to think about identifying the pattern. So as before, we'll go through this example to understand how this works in practice, but first let's briefly talk about this in a general way. So the first thing you should do to use this method is glance at the answers to see what varies most. Is it rotation? Is it count? Does it have something to do with fill? Just glance at the answer options, see what varies the most, and that can be your starting point. Then, 2, you can pick the option that intuitively continues the series. Subsequently, 3, justify it using the frames. So what rule would make this option correct? And does that rule also explain the earlier steps? And then lastly, 4, if you can't justify it cleanly, then reject it and test another option. And this effectively turns guessing into highly structured reasoning, which is exactly what we want to solve figural series questions. So with that, let's go ahead and turn our attention towards our example. Now immediately you might notice that this series can be very confusing at first glance because the black and white patterns are changing drastically. So instead of guessing the rule immediately, you can instead use the answer options to help build a hypothesis. So step 1, as we've just discussed, is to glance at the answer options to find the first feature. So here we have our answer options below the frames, and we can look at the outer edges of A through D to notice a clear split. We see that some of them are squares, so this is where we have corners present, and that's what we see in A, C, and in D, whereas the others, which is actually just B, are crosses. So this is where corners are missing, and that's what we see in B. So the hint essentially revealed by observing this is that this tells you to track the corners in the series. So now let's return back to our frames. In frame 1, we see corners are missing. In frame 2, we see corners are present. Then in frame 3, again, corners are missing. And then frame 4 is what we're predicting. So we see it's alternating between no corners to corners. So because frame 3 has no corners, we would expect frame 4 to have corners. Now the only one of our answer options without corners is B. So for now, we can eliminate B. But this still leaves us with 3 potential answer options, A, C, and D. So this is going to bring us to our next step, which is to compare the remaining options to decipher the center rule. So by center rule, so far, all we've been talking about is these corners, whether they're present or not. But we see something is evolving in the center. In frame 1, we see there is no center. It's solid black. The fill is full. Then in frame 2, we see that some of it has opened. Then in frame 3, we see this cross shape. It's essentially expanding in each of these different directions. And then in 4, again, this is what we are predicting. So with options A, C, and D, let's look at how their white centers differ. And indeed, they actually offer 3 different theories about what's happening to the white center. In answer option A, we see that the white area fragments into 4 separate holes, which you can see here. In answer option C, the white area expands into a larger block. So it's just getting larger and larger, continuously expanding in that same direction that we see going from frames 2 to 3. And then lastly, in D, we see that the white area actually flattens into a horizontal bar. So with that, we can move on to step 3, which is to verify the correct theory using the series. So let's look back at the series and have these 3 theories in mind. If we start again at frame 1, we see it's solid. Frame 2, we have a small white dot or a small white square. And then frame 3, we have the white cross. So the white area isn't breaking apart, as is suggested by A, so we can eliminate A. Then we also see that it's not flattening like in D. It's getting bigger in both the X and the Y. So we can likewise also eliminate D. And that's because it's expanding outwards in all directions. Again, it's not flattening. So frame 3, which is our inner cross, is essentially a central square with arms growing out of it. The logical continuation of this growth is for the gaps between the arms to fill in, creating the large central void that we see in the correct answer option, which is C. It's only answer C that fits the rule of alternating corridors and an expanding center. So C is correct. And it's correct even though it's one of the least intuitive answer options, since we don't see any fragmentation of the black portion of each shape in the series. So to summarize what we've learned in this Figural series completion guide, we covered 3 different methods. The first is the main solving method, which you can consider your initial go-to method to work through most of these problems. The main solving method involves comparing consecutive frames, describing the change you see between frames in one sentence, test the same sentence on the next step, then confirm across all given frames, predict the missing frame before looking at answers, and then finally match to the best answer choice. And again, the main solving method is your go-to method that you should rely on most heavily. But when the main solving method is lacking, we learned two different supplementary methods. The first supplementary method is for rich series to help with fast elimination. So this was our arrow problem, where we focus in on just a single feature and we look only at how that feature changes from frame to frame to help us solve the problem more easily. And then we had supplementary method 2, and this is for series with an unintuitive logic, and it helps to identify and understand plausible processes. So this was our example with looking at the black corners versus the expanding white middle, and again, that was a quite unintuitive problem where it was easier to look at the answer options to serve as our starting point. So all of these three methods can be highly effective. Think first and foremost the main solving method, and then consider where you can use supplementary methods 1 and 2 if you're having some trouble relying on the main solving method alone.